Friends, so today we are going to do the hidden property of the definite integration. So this was the secret property that we were talking about in the video number 15th of the definite integration. So this property I kept hidden from you because this property is very important and a little bit suspense before the actual important thing gets you a better understanding of it. So this property is also known by the name of the king of kings property. So if you remember in the 15th video, in the 14th video we did the king's property, which was defined from 0 to a f of x is equals to 0 to a f of a minus x, where we had dx both the side. So this was the king's property, but now we are in this property we are gonna discuss a property that is the origin of the king's property. That's why it is called the king of kings property. So the property says, the actual property of the that we are going to discuss today is defined from limit a to b, where a and b can be any natural numbers. So when we have fx and we got to integrate it with respect to x, we can just write it from a to b as f of a plus b minus x dx. So at the first sight it might seem to you that it is very much similar to the king's property, but there's a bit difference because in king's property we had a 0 in the lower limit, but here both the limits a and b both are variable limits, whereas in the king's property we had only one variable limit in the, that is the upper limit. Now the king's property is the special case of this property. When we put a is equals to 0, we get 0 to b f of x dx is equals to 0 to b f of b minus x dx. This is king's property. So by putting so king's property is the special case of this property. So now since now we know that this is the property, let us do some questions on it. The questions on it are very similar to the questions we did on the king's property. It's just that they are a bit twisted, but the concept remains the same. So a to b f of x upon f of x plus f of a plus b minus x. So f can be any function, we have not defined it yet, but we can just simply solve it for any of the functions by applying this property. We know that we can just directly write a plus b minus x upon f of a plus b minus x plus f of, now applying here we have a plus b as they were, minus, now we are gonna substitute the a plus b minus x value in the x as it is. So we have a plus b minus x over here. Now after solving this we get a and b cancelled and there is a plus x left with us. So this is very similar to the question we had. So we can actually term this question as I, and this is again I because both the terms would be equal. So 2i, adding both of them, we get a to b f of x plus f of a plus b minus x upon f of a plus b minus x plus fx. So both of them get cancelled out and we are just left with the x over here with limits a to b, 2i. So I is equals to b minus a, that is upper limit minus the lower limit, upon 2. This is the value of I. So let's take another question. This is our final answer to the question above. Let's take another question. The question is, now this question is where the trick begins, and we need the rule more in this property, that is under root sine x upon under root sine x plus under root cos x dx. Now if you remember, we did the similar question in the king's property where we had a 0 to pi by 2 as our final limits, but we have a pi by 6 and a pi by 3 as our limits. So we need to configure something to make this question work out easier for us, so we can actually just apply the king's property, the king of kings property over here. So we have let this question be I, and we have pi by 6 to pi by 3 under root sine. Now the striking factor that you should know is pi by 6 plus pi by 3 is equals to pi by 2. Now this is what makes the king's property fail over here, because because in the king's property we had 0 to pi by 2, but now we have used the king of kings property to make suitable limits for us. So just directly writing this, we have pi by 6 plus pi by 3, that is pi by 2 minus x upon under root sine pi by 2 minus x plus under root cos of pi by 2 minus x dx. Now solving this further, we have pi by 6 and pi by 3. Now we know that sine 90 minus theta is sine theta, and in the under root also we get cos x plus sine x dx. So this is also equal to I. Now the question was an I, and here we have another I. Now adding both of them, the question and this final term that we had, so we have pi by 6 and pi by 3. So we have under root sine x plus under root cos x upon under root sine x plus under root cos x dx. So both of these terms get cancelled again, and we are left with the x with upper and lower limits as pi by 6 and pi by 3 respectively. So now 2i is equals to pi by 3 minus pi by 6. So we can get a pi by 6 over here, which is equal to 2i, and the final value of I would be pi by 12. So this is our final answer. Moving on to the last question of this video, we have 4 to 10 as our limits, and greatest integer of x upon greatest integer of x plus 14 minus x dx. Now we have a greatest integer function, but rather than breaking it into simpler pieces from 4 to 10 like we did in the second or third video, that we break the function into the parts that is continuous in it, but breaking it into some parts would not be beneficial for us, because we would get so many parts from 4 to 10, because the greatest integer function breaks at the integer, and we have 6 integers over here, which is not at all very beneficial for us. So it will break at 7 points. So we cannot just break it into 7 points and solve. Rather than we just need to apply the king of kings property. So we have 4 and 10 and 14 minus x upon x plus 14 minus x dx. We have actually applied the king's property over in the denominator as well. It's just that you cannot see the difference, because you would get a 14 minus x. The denominator would be same, because 14 minus x and 14 minus x would you will get in the denominator. So this is equal to I, and this is again equal to I. Now adding both of them, we get 2i is equals to 4 to 10 14 minus x plus x upon x plus 14 minus x. Both of these terms get both the numerator and denominator get cancelled again, and we are left with a x with lower limit as 4 and the upper limit as 10. Further solving this, we get 10 minus 4 upon 2, which is equal to 3. So the final value of I is 3, which is our final answer. So we have completed 3 questions and our hidden property finally in this video. Thanks for watching.